In this course, we are going to study chemistry and apply it to cosmetics. So, one of the first things that you may be asking yourself is, what is a cosmetic? Now, the word cosmetic shares its origin with cosmos from the Greek cosmos. So, when we talk about this, we're talking about cosmos there, which is described as order or ornament. Okay? And that word ornament has led to cosmetics being used to describe the outer appearance. The focus on surface or superficial matters has also led to the interpretation that cosmetic products are somehow trivial or really lacking in depth. The ornamentation definition leads many to think that the term cosmetic product just applies to makeup. Now, makeup, which is sometimes called color cosmetics or decorative cosmetics, is just really one class of cosmetic product. And there are many different classes of cosmetics products used by millions of consumers every day. So, then what is a cosmetic? Well, cosmetics are composed of mixtures of chemical compounds that are derived from either natural sources or synthetically created they focus on the appearance of the outer body surfaces. And these include things like skin, hair, and teeth. And particularly focus on keeping these surfaces clean, perfuming them, or correcting body odors. So, cosmetics and personal care products are applied to the human body for the purposes of cleaning or beautifying or promoting attractiveness or changing its appearance. And so this can include things like lotion, shampoo and conditioner, soaps, and then color cosmetic products. Now, each area of the world will also have its own legal definition of a cosmetic product. And although there's a lot of commonalities, some products classified as cosmetics in the UK and the European Union are classified as different product types in other areas of the world. So, for example, sunscreens are cosmetic products in the UK and the European Union, but are over the counter medicines in the US. Hair dyes are cosmetic products in Europe and the US, but are classified as kind of quasi drugs in Japan. So, different areas of the world can have a different legal definition of what they consider to be a cosmetic. So, let's look at the different types of cosmetics and their frequency of use. So, these are two charts that came from Cosmetic Europe website. So, it's just the cosmetic products. And when we look here at the different types of cosmetics, it branches out into things like sun care, so lotions and creams, sprays, hair care, right? And we can see shampoos and serums, mousses, hair colorants, decorative cosmetics, like some of the things I think we naturally think about: eyeshadow, mascara, blushes, nail varnishes, that's like nail polish, perfumes, body care, soaps, deodorant, body washes, shower gels, scrubs, oils, body lotions, then skincare, facial masks, shaving cream, exfoliators, toners, eye cream, and then oral care, flossers, mouthwashes, and toothpaste. So all of these are different cosmetics that are part of people's everyday lives. Then I found this also really interesting at the same website, where it's the frequency of use, so the number of times per day for a sample of cosmetics. And so on this side, this is adult women, and then on this side, this is adult men. And so it's the number of times per day they use on average each of these different cosmetics. So, what goes into a cosmetic product? Now that we have defined what cosmetics are and we've established that people use cosmetics, what goes into the product? So cosmetics will have a list of ingredients on the back of a product. What I'm showing you here is a list of ingredients from Dove body wash. When we look at these ingredients, this is just a legal requirement that's designed to help people identify products that they know they're sensitive to or allergic to. The European market implements the International Nomenclature of Cosmetic Ingredients. That is abbreviated as INCI. And these are names based on chemical identity and structure. And a lot of the cosmetic companies have adopted this. Now, a few things to keep in mind. The ingredients here on cosmetics are not a recipe. The ingredients used in greater than 1% are listed in order of concentration. So if we look here, that means water is going to be in the highest concentration, with this as the second highest concentration, and sodium hydroxyl propyl starch phosphate as the third highest concentration. Now, those that are less than 1% can be included in any order. So ingredients that are greater than 1%, let's pretend like I spelled that right, greater than 1% are in order of concentration, right? If it's less than 1%, it can be in any order. And so the question is, where is that cutoff? And that's a really hard question to ask. There's nothing when we look here that shows us where a cutoff is. So a tip when we're trying to identify these lesser ingredients is to look for common preservatives. Things like benzoic acid or parabens or phenoxyethanol. And then the other thing to look for is the term fragrance, because the fragrances there are things below that fragrance will be listed as 1%. So when we look at this, we can see fragrances right here. So it's a pretty safe bet. And then here's that phenoxyethanol that's also used as a preservative. So it's a pretty safe bet that when we look at this, these things here are in a lower concentration than 1%. Now, that means that we're not sure about glycerin, right? We're not sure about sodium chloride. But below this fragrance, we can pretty much say everything here is listed as less than 1%, and it's listed in any order. Now, if anyone reacts so badly to a cosmetic they have to see a dermatologist, the company will release the full details, including the levels of use, to healthcare professionals. And that's just to kind of help the healthcare professionals assess what happened. Now, once that allergy has been diagnosed, the individual can avoid those ingredients in the future. So let's define a few terms that we're going to run into when we talk about these cosmetic processes. One of the terms that I have run into quite a bit is a chassis, or base or workhorse, and these are really used interchangeably. All this is this is the ingredient that creates a product structure and stability. And its purpose really is to act as a vehicle to deliver the active ingredient. And I think that's where this word chassis came from, or workhorse. It's this idea of movement, that we're moving this active ingredient. Now, let's talk about the active ingredient. This is just the specific component that's designed to produce a targeted effect. Sometimes it can be on your skin or hair or nails, but you want this targeted effect. A few other things to keep in mind is an ingredient may have more than one function. Unlike medicine, where one active ingredient or ingredient combination is responsible for the therapeutic effect, you can have several cosmetic ingredients that are blended together to provide a combination of benefits. In this class, we are going to learn about several cosmetics: soaps, lotions, color, cosmetics, perfumes, shampoos, all of those, as well as their active ingredients. Now, to be able to do this, we'll need to learn about several chemical principles. And so the first part of this class will be building our chemistry knowledge. And then the second part of the class will be applying it towards understanding the products and their ingredients. So let's talk about chemistry for quite a bit. When we start talking about chemistry, it's really helpful to define what chemistry is. Chemistry is just the study of composition, structure, and the properties of matter, right? And so what chemists do is chemists observe the changes that matter undergoes. Right? And then they measure the amount of energy produced or consumed during those changes. Now, chemists use the scientific method. And when we talk about the scientific method has several steps, which we see here. We collect information, we formulate a hypothesis, we test the hypothesis using experiments. We can formulate a law or formulate a theory or law, right? And then we repeatedly go back and test that, okay? So I want to give some definitions to this. So when we talk about an observation, we're observing something, we're looking at something, we see something, and then we try to organize all these observations by identifying the patterns and regularity. And a lot of times we ask ourselves, why? And so we try to explain those observations in some way with a hypothesis. So a hypothesis is a statement that tries to explain the observation. A big thing here is you can't prove a hypothesis. Scientists get real sticky about this word prove. So you cannot prove a hypothesis. Basically because prove is so concrete, right? You can't prove it, but you can disprove a hypothesis. Now, we test a hypothesis by designing an experiment. And designing an experiment, just honestly, as a scientist, is what I spend most of my time doing. And the big thing about experimental design that you need to remember is you only change one variable at a time. Now, we've got two different variables that we talk about when we talk about experiments. One variable is the independent variable, and this is just the variable that is changed by the scientist. We can also have the dependent variable, and this is the variable that changes in response to whatever that scientist changed. So to the independent variable. So, for example, time spent studying causes test scores to increase. When we look at this, there are two things that can change in the statement. The time spent studying is one, and the other thing that we can see a change with here is that the test scores, right? And so the thing that the scientist is changing is the time that's spent studying. So that's independent. That's the thing that we have control over. And then the result of that is that value of the test score. And so that's an example of a dependent variable. Two other definitions that we run into with the scientific method are law and theory. A law summarizes a broad variety of observations and experiments. And the key word there is summarize. Now, a theory will explain why something happens, or it will make predictions. And the big theory that we talk about in chemistry is atomic theory. We also run into some laws in some chemistry classes we won't hear that are called gas laws. So let's talk about matter for just a second. So chemists are studying matter, right? And so the definition of matter is this is anything that has mass and takes up space. Okay. And then we also study the properties of matter. Properties are just the characteristics scientists use to categorize different types of matter. There's a couple ways we can categorize matter. We can categorize it by state. This is things like solid, liquid, and gas, or by composition. And that's what we're going to talk a little bit about in the next few slides. So when we talk about categorizing matter by composition, we can talk about physical properties and chemical properties. Now, physical properties are observed without changing the composition or identity of the substance. So a really good example of this is things like the melting point. Right? If an ice cube melts, it's water when it's in the liquid state, and it's water when it's in the solid state. That's an example of a physical property. Now, what we just described with that, as we're going from the solid to the liquid state, is a physical change. Physical change is just where you have a recognizable difference in the appearance of a substance without causing any change to its identity. And so an example of this would be like melting, freezing, boiling, those types of things. Now we can also have chemical properties. Now chemical properties result in a change in composition. Right? These are things like flammability, right? And they can really only be observed through a chemical reaction. And so another word for a chemical reaction is a chemical change. So it's also known as a chemical reaction. And this is just when a chemical substance is converted into a different substance. We use a chemical reaction to convey this. So for example, we see this flammability here. This is a Bunsen burner. We see there's a flame here. And what's happening here is we have propane gas, which is C3H8, and it reacts with oxygen gas. And it forms CO2 and water. So this is a chemical equation. It's helping us see the chemical change. We will talk about chemical equations a lot after spring break. There's a lot of things we're going to talk about before, but it's really helpful, particularly in lab, for you to know that the reactants, the things that we put together, are on the the left side of the reaction, and the products here are on the right side. Okay, and so this is what we react together, and this is what we kind of get out of that reaction. And so that's really helpful here, and the arrow separates the two. Now, we can also talk about the different states of matter. We have solids, liquids, and gases. Solids have a definite shape and a definite volume. And their atoms are locked in place. The picture here is a picture from like a geyser, not a geyser, but it's from Yellowstone. It's one of the pools that they have where you have ice, like snow on the side, and then they are very, very hot, and so you see steam, but you also see a liquid. And so if we're trying to visualize a solid, this is the atomic view of a solid here with the ice. So those are locked into place. Those atoms are locked in place. We can also have liquids. Here is the atomic view of a liquid. In a liquid, we say that these have a definite volume, but an indefinite shape. That just means that the shape can change, right? A definite volume means that that is not going to necessarily change, but that indefinite shape means that it can take the shape of the container. These atoms are in close proximity. but move past each other. Now the gases, right, these are vapors sometimes called, and they don't really have a definite shape or volume. So we say there's no definite shape or an indefinite shape or volume, right? Now the big thing here is these particles are widely separated and these can be compressed. All that means is they can be kind of smushed together. We then can describe these solids and liquids here as incompressible. Right? Because they have this definite volume, we cannot squeeze them together anymore. When we talk about the atoms here in a gas, they are very, very far apart. Now, one of the things we've already talked about is that we can have transformations from one state to another. And these are a lot of times called phase or state changes. And so this just occurs when there's a transformation from one state to another. And so we can see this here in the terms that are used for this. So if you go from a solid to a liquid, that's melting. A liquid to a gas is vaporization, sometimes called evaporation. And then from a solid to a gas is sublimation. If you go from a gas to a solid, that's deposition, right? If you go from a liquid to a solid, that's freezing. And a gas to a liquid is condensation. So those are the different phase changes. I want to point out the chemical structure is not changing here. This is not a chemical change. Now, another way to classify matter is based on whether it's a pure substance or a mixture. When we talk about a pure substance, right, this is just a substance with only one component. You can also have a mixture, and this is just a combination of two or more pure substances. Right? Now, each will retain its own identity, not undergoing a chemical reaction. You'll hear a definition a lot of times of a pure substance. It's not my favorite, but it's worth mentioning, is that these can't be broken down any further by physical means. So that means we can't separate them by boiling and using different boiling points to separate them. We can't separate them by filtration. That's just another way to say it. But I like when I view it as a substance with only one component. So I want us to talk about our pure substances for just a second. With our pure substances, we have two different types, right? The first type is an element. There are only 118 of these. They are found on the periodic table. You can also have a compound. A compound is just where you have two or more elements that are chemically bonded together. So this would be something like water. Water, the chemical formula for water is H2O. That means there are two hydrogen atoms for every one oxygen atom, but these are bonded together. These cannot be broken into the individual elements by physical reactions, right? It would take a chemical reaction to break these apart. So I want us to look just really briefly at the elements, and I want to point a few things out. Again, we will talk about the periodic table more in depth later in the course, but I want you to notice a few things here. When we look at these atoms, this is the 118 things that are elements. We have an updated periodic table I'll give you in class with the names of these elements here. You're going to see they're arranged in increasing atomic number. I also want to point out these horizontal rows are called periods, and the vertical rows here are called groups. So those vertical columns here are called groups. Now those groups contain elements with similar properties. So we'll be able to say things like everything in this group reacts in this way later. I've also mentioned a few times here chemical formulas. It tells us the type and number of each element present using the subscript. So when we look at this, we have 2 hydrogen atoms and 1 oxygen atom in a chemical formula here. Sometimes in chemical formulas, you are going to run into parentheses like this. What that means is you take anything in the parenthesis and multiply it by the subscript here. So when I look at this particular element here, or this particular compound here, not element, compound, and I take each of those elements out and look at their numbers, I have 1 calcium atom, I have 2 oxygen atoms, and then I have 2 hydrogen atoms. So when we look at both of these would be classified as compounds. Okay. So let's take a look at mixtures. In mixtures, we have 2 kind of classes of these. We have homogeneous and heterogeneous. A mixture is just a combination of 2 or more pure substances. If it's a homogeneous mixture, it has a uniform distribution through the sample. All that means is the sample is uniform. It's the same thing. It has no visible boundaries. Or regions. Another word for this is a solution. A really good example of a solution is vinegar. Vinegar is a mixture of many different things, but it is referred to as a solution because we have like acetic acid molecules and water, things like that. We can also have heterogeneous mixtures. These components are not uniform, distributed, and have distinct regions. Of different composition. And a good example of that is salad dressing here. You can see that there's 2 different regions here. Sometimes your makeup removers will have an oil-water mixture. Those are an example of heterogeneous. They have 2 different areas there. So a really helpful summary that we run into here is this flow chart. We start here and we have all matter, and can it be separated by physical processes? If the answer is no, then it's a pure substance. So it's something like an element, but I really like to just ask myself first, is it found on the periodic table? Because periodic tables, like if it's an element, it's going to be there. That's what it's going to be. And then a compound is going to be just one thing that's held together by different bonds. So what do I mean by that? It's just going to be water, H2O, all by itself. It's not mixed in with anything else, but it has 2 or more atoms that we find on the periodic table, but they're held together with chemical bonds, not mixed with anything else. We can then have a mixture where if it's a uniform composition, it's homogeneous. If it is not a uniform composition, it's heterogeneous. One last classification before we end this screencast is that we can also classify matter as intensive or extensive. Intensive properties are just a property of matter that is independent of the quantity of the substance. Examples of this are things like color, right? Density. We'll talk about density here in a couple days. Melting point, right? Whether you have a lot of ice or a little bit of ice, it's going to melt at the same temperature. You can also have extensive properties, and these are a property of matter that depends on the quantity of a substance. Examples of this are things like mass and volume, right? They're going to change. If you have a little bit, you got a lot of mass, right? If you got a little bit, you have a very little bit amount of mass. If you have a lot of it, then you have a lot of mass. Same thing with volume. Volume is going to be really small for a little bit, much larger if you have a lot. Those are extensive properties. All right, so through this screencast, we have kind of done an introduction to chemistry. And cosmetics. We've talked about the basis of cosmetics. We have talked about chemical and physical properties and several different ways that you can classify matter. In the next screencast, we are going to talk about measurements.